Chapter 6, Learning. Learning. Loggerhead sea turtle hatchlings are born knowing how to find the ocean and how to swim. Unlike the sea turtle, humans must learn how to swim and surf. As humans, we pride ourselves in our ability to learn. What processes are at work when we come to know what we know? Unlearned behaviors. There's instincts and reflexes. Instincts and reflexes are innate behaviors that organisms are born with. Help organisms adapt to their environment. Reflexes are motor neural reactions to a specific stimulus. They're simpler than instincts. They involve the activity of specific body parts. They involve primitive centers of the CNS, the spinal cord and medulla. Example, human babies are born with a sucking reflex. Instincts. Behaviors triggered by a broader range of events, such as aging, change of seasons. This is more complex, involve movement of the organism as a whole, such as sexual activity, migration, and involve higher brain centers. What is learning? Learning also helps organisms adapt to their environment, but learned behaviors involve change and experience. Learning, a relatively permanent change in behavior or knowledge that results from experience. Involves acquiring skills or knowledge through experience, involves conscious and unconscious processes. Associative learning, when an organism makes connections between stimuli or events that occur together in the environment. There are many approaches to learning. We will look at approaches that are part of behaviorism, so classical conditioning, operant conditioning, and observational learning. In operant conditioning, a response is associated with a consequence. This dog has learned that certain behaviors result in receiving a treat. Classical conditioning. Ivan Pavlov's research on the digestive system of dogs unexpectedly led to his discovery of the learning process known as classical conditioning. Classical conditioning is a process by which we learn to associate stimuli and consequently to anticipate events. Pavlov noticed that dogs salivated not only at the taste of food, but also the footsteps of the lab assistants. He realized that organisms must have two types of responses to its environment: unconditioned, so unlearned, responses, and conditioned, learned responses. In the most famous example, dogs were conditioned to associate the sound of a bell with food. When the dog heard the bell, they anticipated food and began to salivate. So how does classical conditioning occur? Before conditioning, there's an unconditioned stimulus, a UCS, a stimulus that elicits a reflective response, such as food. And there's the unconditioned response, UCR, a natural, unlearned reaction to a stimulus, salivation in response to food. So food equals salivation. During conditioning, there's a neutral stimulus, NS, the stimulus that does not naturally elicit a response. Ringing a bell does not cause salivation by itself prior to conditioning. The NS and UCS are paired repeatedly. Bell plus food equals salivation. After conditioning, conditioned stimulus, CS, stimulus that elicits a response after repeatedly being paired with an unconditioned stimulus. Conditioned response, CR, the behavior caused by the conditioned stimulus. Bell equals salivation. So classical conditioning, dog salivates in response to food. Dog does not salivate in response to bell. That is before conditioning. During conditioning, the bell and food are paired. After conditioning, the bell causes salivation. Higher ordered conditioning. Higher order conditioning is an established conditioned stimulus that is paired with a new neutral stimulus, the second order stimulus, so that eventually the new stimulus also elicits the conditioned response without the initial conditioned stimuli being present. Example, the cat is conditioned to salivate when it hears an electric can opener. The squeaky cabinet door, second order stimulus, is paired with the can opener. The cat salivates when it hears the squeaky cabinet door. The cat learns to associate the cabinet door with electric can opener and therefore with food. General processes in classical conditioning. Acquisition. The initial period of learning when an organism learns to connect a neutral stimulus and an unconditioned stimulus. Usually this requires there to be a very short time interval between the NS and the UCS and for the pairing to repeat multiple times. Sometimes conditioning can occur when the interval is up to several hours and the pairing occurs only once, such as taste aversion. Extinction. Decrease in the conditioned response when the UCS is no longer represented with the CS. If food stops being presented with the sound of the bell, then eventually the dog will stop responding to the bell. Spontaneous recovery. The return of a previously extinguished conditioned response following a rest period. Curve of acquisition, extinction, and spontaneous recovery. The rising curve shows the conditioned response quickly getting stronger through the repeated pairing of conditioned stimulus and the unconditioned stimulus, the acquisition. The curve decreases, which shows how the conditioned response weakens when only the conditioned stimulus is present, extinction. After a break or pause from the conditioning, the conditioned response reappears, spontaneous recovery. Distinguishing between stimuli. Organisms need to be able to distinguish between different stimuli in order to respond appropriately. Stimulus discrimination. When an organism learns to respond differently to various stimuli that are similar, the dog can discriminate the specific bell sound that signals food and a similar bell sound that does not signal food. Stimulus generalization. When an organism demonstrates the conditioned response to a stimuli that are similar to the conditioned stimulus. If an individual learns to dislike a specific spider, they will usually then dislike all spiders. Classical conditioning can also lead to habitation. Habitation is learning not to respond to a stimulus that is presented repeatedly without change. As the stimulus is repeated, we learn not to focus our attention on it. Behaviorism. John B. Watson used the principles of classical conditioning in the study of human emotion. He believed that all behavior could be studied as a stimulus-response reaction. Believed the principles of classical conditioning could be used to condition human emotions. Conducted a famous study with little Albert. Little Albert. Watson exposed little Albert to certain stimuli and conditioned to fear them. Presented with neutral stimuli, a rabbit, dog, cotton wool, and a white rat. Watson then paired these with a loud sound every time little Albert touched the stimulus that caused him to feel fear. After repeated pairings, little Albert became fearful of the stimulus alone, such as the white rabbit. Although initially conditioned to fear specific stimuli, they were all furry, and therefore, through the stimulus generalization, little Albert came to fear furry things, including Watson in a Santa Claus mask. There is no evidence whether little Albert's fear was long-lasting or not. Operant conditioning. Operant conditioning is a theory proposed by B.F. Skinner. In operant conditioning, organisms learn to associate a behavior and its consequences, reinforcement or punishment, based on the law of effect. Pleasant consequences, or a desired result, equals a behavior that is more likely to occur again. Unpleasant consequences, or undesired results in behavior is less likely to occur again. When we show up to work, a behavior, we get paid, pleasant consequence, so we continue to show up to work. Skinner conducts experiments, mainly with rats and pigeons, to determine how learning occurs through operant conditioning. So, operant conditioning terminology. Positive, to add to something. Negative, to take something away. Reinforcement, increase a behavior. Punishment, decrease a behavior. The Skinner box. To study operant conditioning, Skinner placed animals inside an operant conditioning chamber, the Skinner box, containing a lever that when pressed causes the food to be dispensed as a reward. Reinforcement. Positive reinforcement. Something is added to increase the likelihood of a behavior. Everyday examples: high grades, paychecks, praise. Negative reinforcement. Something is removed to increase the likelihood of a behavior. Everyday examples: the beeping sound that will only go away when you put your seatbelt on. Sticker charts are a form of positive reinforcement and a tool for behavior modification. Once this little girl earns a certain number of stickers for demonstrating a desired behavior, she'll be rewarded with a trip to the ice cream parlor. Punishment. Positive punishment. Something is added to decrease the likelihood of behavior. Scolding a student for texting in class. Negative punishment. Something is removed to decrease the likelihood of behavior. Taking away a favorite toy when a child misbehaves. Timeout is a popular form of negative punishment used by caregivers. When a child misbehaves, he or she is removed from the desirable activity in an effort to decrease the unwanted behavior. For example, in picture A, a child might be playing on the playground with friends and push another child. So in picture B, the child who misbehaved would then be removed from the activity for a short period of time. Shaping is a tool used in operant conditioning. In shaping, instead of rewarding only the target behavior, we reward successive approximations of target behavior. Behaviors are broken down into many small, achievable steps. useful when teaching a complex chain of events, commonly used by animal trainers. So reinforce any response that resembles the desired behavior. Then reinforcement the response that more closely resembles the desired behavior. No longer reinforce previously reinforced response. Then begin to reinforce the response that even more closely resembles the desired behavior. Continue to do this until only the desired behavior is reinforced. Primary and secondary reinforcers. Rewards to reinforce behavior can come in many forms, such as praise, stickers, monies, toys, etc. Primary reinforcers, those that have innate reinforcing qualities, such as food, water, sleep, sex, pleasure. The value of these reinforcers does not need to be learned. Secondary reinforcers, those that have no inherent value. The value is learned and becomes reinforcing when linked with a primary reinforcer. Praise. A secondary reinforcer is linked with affection, a primary reinforcer. Money is only reinforcing when it can be used to buy other things, such as things that satisfy basic needs, such as food, or other secondary reinforcers. Tokens are a secondary reinforcer that can be used in exchange for other things. Token economies are used in many settings to encourage correct behavior, such as prisons, schools, and mental institutions. Reinforcement schedules. The best way to teach a behavior is with positive reinforcement. However, there are many ways that the positive reinforcement can be administered. Continuous reinforcement. When an organism receives a reinforcer each time it displays the behavior. Quickest way to teach a behavior. Example, a dog receives a treat every time it sits when told to do so. Timing is important. The treat must be presented immediately after sitting in order for the dog to associate the target behavior with the consequence. However, if the trainer suddenly stops providing treats, the dog will stop sitting, so another type of reinforcement is then used once the behavior is learned. Partial reinforcement. The organism does not get reinforced every time they display the desired behavior. They are reinforced intermittently. There are several types of partial reinforcement schedules. There's fixed versus variable. Fixed is the number of responses between reinforcements, or the amount of time between reinforcements is set and unchanging. There's variable. The number of responses between reinforcements, or the amount of time between reinforcements, varies or changes. There's also interval versus ratio. Interval is the schedules based on a time between reinforcements. Ratio is the schedules based on the number of responses between reinforcements. So fixed interval reinforcement is delivered at a predictable time of intervals. Patient takes pain relief medication at set times. Variable interval reinforcement is delivered at an unpredictable time intervals, checking Facebook. Fixed ratios reinforcement is delivered after a predictable number of responses. Factory worker is being paid for every X number of items manufactured. Variable ratio reinforcement is delivered after an unpredictable number of responses, such as gambling. The four reinforcement schedules yield different response patterns. Variable ratio schedule, unpredictable and yields high and steady response rates with little if any pause after reinforcement. So example, gambler. Fixed ratio schedule, predictable and produces a high response rate with a short pause after reinforcement. Eyeglass saleswoman. Variable interval schedule, unpredictable and produces a moderate steady response rate. Restaurant manager. Fixed interval schedule yields a scallop-shaped response pattern reflecting a significant pause after the reinforcement. Surgery patient. Gambling in the brain. Some research suggests that pathological gamblers use gambling to compensate for abnormally low levels of the hormone norepinephrine, which is associated with stress and is secreted in moments of arousal and thrill. Cognition and latent learning. Research conducted by Edward C. Tolman found that learning could still occur without reinforcement. This introduced the idea that there is a cognitive aspect to learning. While studying rats, he found that if we put them in a maze to learn their way through it, they would eventually form a cognitive map of it. A cognitive map is a mental picture of the layout of an environment. After 10 sessions in the maze without food, as reinforcement, food was placed at the exit, and the rats were able to very quickly exit the maze, showing they had learned the way out. This is called latent learning. Latent learning is learning that occurs but is not observable in behavior until there is a reason to demonstrate it. Children may learn behaviors from their parents that they do not demonstrate until they are older. A child may learn the route to school from watching his parents drive there, but will not demonstrate this until they can drive themselves or have to get there by bike, walking, etc. Psychologist Edward Tolman found that rats use cognitive maps to navigate through a maze. Have you ever worked your way through various levels on a video game? You learned when to turn left or right, move up or down. In that case, you were relying on a cognitive map, just like the rats in a maze. Observational learning, such as modeling. Observational learning is learning by watching others and then imitating. Model, the individual performs the intimidated behavior. This spider monkey learned to drink water from a plastic bottle by seeing the behavior modeled by a human. Yoga students learn by observation as their yoga instructor demonstrates the correct stance and movement with their students. Live model. Models don't have to be present for learning to occur. Through symbolic modeling, this child can learn a behavior by watching someone demonstrate it on television. Social learning theory. In order to explain how learning occurred without external reinforcement, Albert Bandura proposed social learning theory. He believed that observational learning involves more than just imitation, and that internal mental states must be involved. Steps in the modeling process: attention, retention, reproduction, and motivation. Attention is focus on the behavior, retention is remember what you observed, reproduction is be able to perform the behavior, and motivation is you must want to copy the behavior. Motivation depends on what happened to the model. There's vicarious reinforcement, process where the observer sees the model is rewarded, making the observer more likely to intimidate the model's behavior. There's vicarious punishment, processes where the observer sees the model punished, making the observer less likely to intimidate the model's behavior. Bandura's Bobo doll experiment. In a famous study known as the Bobo doll experiment, Bandura studied modeling of aggressive and violent behaviors. Children observed adults act aggressively to a 5-foot Bobo doll. The adult was then either punished, praised, or ignored for their behavior. The children were given the opportunity to play with the Bobo doll. If the child had seen the adult punished, they were less likely to act aggressively towards the doll. If the child had seen the adult praised or ignored, they were more likely to imitate the adult. Bandura concluded that children watch and learn from adults around them, which can both pro-social and antisocial consequences. Can video games make us violent? Psychological researchers study this topic and suggest that there is a correlation between watching violence and aggression in children. So this is it for our chapter. Thank you and have a good rest of your day.